Hey everyone, this is Ryan Jones from Serverless Guru. In this video, we are going to be reviewing another video by the AWS team on serverless. So in the last video, we talked about a serverless overview of S3 and how it connects to Lambda to do things like image processing. In this video, it's going to be another one on using S3 with Lambda for file uploads. Let's go ahead and get into it.
Data is uploaded to a server, which may save the file in some.
Let's actually rewind it. There we go. Okay.
Hi everyone, this video will show you how to take a serverless approach to handling file uploads, all without using a server. For applications that allow end users to upload pictures and other media, one of the common problems is the amount of work involved in uploading and processing these files. Typically, the binary data is uploaded to a server, which may save the file in some local temp storage before saving it permanently somewhere else. Because of the sheer size and quantity of these files, it takes a fair amount of compute, so it's common to have fleets of servers handling file uploading processes for popular applications. The serverless approach allows your application to use a pre-signed URL and upload directly to Amazon S3. This offloads all of the bandwidth and compute requirements away from your application and instead relies on the massive scalability of S3. You can use this method in any type of web application, even ones that are not serverless, like WordPress, for example, or other LAMP stack applications. If you're using servers, doing this will free up your server to handle other requests. Let's take a look at the console and see how it works. So first, I'm going to create a bucket. I'll call it JBezwa Uploads.
Real quick, I'm actually just going to increase the speed. I think that potentially for others, I guess I wonder, you could potentially slow down the speed of the video by a little bit and it'll offset it, but I'm gonna probably put this at like 1.5 speed just so that I'm fully paying attention. I'm
using Northern California as my region in this case. I'm
can't
going
see
to
how
allow
close it
public
is.
access. You don't have to do that, but just for this example, I'm going to make this a public bucket. Okay, so now we see our bucket. And right now there's nothing in there. So first things first, I need to set a CORS configuration on the bucket. I have a pre-canned configuration I'm going to use just for this example. It's got a start origin. You wouldn't normally do this in a production application, but for a demo, it's okay. I'll just save this CORS configuration here.
Yeah, so the reason why you wouldn't do that in production is because it's gonna allow full access there. Um, So it's not following least privilege. There's actually a few things when you dive into the AWS documentation, or even in most examples. I mean, we even do this with our examples of Serverless Guru. It's much easier when you're making a demo to use a star pattern and not make it a deep dive about IAM and identity access management versus obviously having the best permissions and least privilege and all that stuff. So it makes sense here. What he's done is he's created a S3 bucket called uploads. He set up the I believe it was the access control. Those are the core configuration. Okay, so core configuration set up. There was block public access here. I believe that he took it off. Yes, that's going to allow the bucket to be accessible. We have the course configuration on there. And finally, let's move back to where we were and play it.
And now let's go to Lambda. I'll create a new function, and I'll call this getPreSignedURL. I'm using Node.js 12, and just creating this function which takes a few seconds.
So in the last video, we talked about pre-signed URLs as being able to have a private bucket and then be able to send back a pre-signed URL, which you could then use to then upload or get objects out of that private bucket. And yeah, it's a pretty awesome use case. It looks like that's what James is about to jump into. Let's keep going.
Okay, now we have our function. I'm going to replace the code in the handler here with some code that we have in the GitHub repo. I'm just copying this over, replace this and paste this code. Now to show you what this does, this is a standard Lambda handler at the top. It calls this function called getUploadURL. We're going to use a random ID for the file name of the object, and then it takes the upload bucket from the environment variable, and it's expecting a JPEG file. We're going to set an ACL of public read, so these files will be publicly readable. And then further down, all we're doing is calling this getSignedURL function to get the pre-signed URL from the S3 service. Once it gets that, it returns the result. Now we need to just set up this environment variable upload bucket. So down here,
Okay, so one thing to point out here is that, yeah, so basically, as you were saying, on line 6 there, if you can see that, that's your exports.handler. So this is going to be the main entry point for Lambda functions. Typically, people call it handler. You can call it something else, but then you have to define that properly. I typically leave it as an exports.handler and just go from there. After that, you can see the async there. So this is an async await function. You can see that the only argument being passed into this handler function for your Lambda function is actually just the event. If you go back in time a little bit before the async await, before the Node.js 12, if you go back to like Node.js 8, all that stuff, people still actually code some of the stuff this way, but it's moving away from that very, very fast. Before, you would have 3 arguments. You had event, context, and callback. You can still pull in the context. There are use cases to pull in the context when you're building Lambda functions. One of them is that you can see the timeout and how long before the timeout comes. So if you set a 15-second timeout on your Lambda function and you're already at, let's say, 10 or 12 seconds and you're doing processing still, you can actually check for that. And if it's there, then you can stop it. And that might be storing the last state somewhere inside of DynamoDB, not accepting any more messages from a queue, etc. And then once we get down a little bit further, you can see here that we've got the get upload URL function. That's going to be an async function as well. You can see down here on line 15 through 20. So this is the parameters. So every AWS SDK, and the AWS SDK is actually how you interact with AWS services, there's always a params object. And that params object has a few standard arguments. One of them is always some type of ID. In this case, on line 16, we have bucket. And so bucket is literally representing the exact address of the bucket. So that might be the bucket name. For other resources, that might be the ARN, which is the Amazon resource name. So it's going to be kind of like an ARN for Amazon is pretty much like an address, right? Like you have an address for your apartment or your house, and that's what an Amazon resource name is, or ARN. And so some of the AWS SDK calls will require a resource ARN. Some of them will require the name of it. Some will require the ID. It just depends on the actual API call that you're making to AWS SDK. In this case, it's just a bucket name. We're also giving it a key because we're going to upload something. So we're giving it a key of that random ID on line 13. And then we say .jpg, so it's going to be an image. We're saying the content type is image/JPEG. From my experience, sometimes S3 will pick that up, but you definitely want to be specific. Last thing you want is for the content type to be assumed by S3 incorrectly and then cause downstream bugs. The other part that you want to look at is the ACL there. The ACL is your access control list. Right here we're saying public read, which means that anybody can read it. You can also add a whole bunch of different ACL types, and you can find all those in the AWS documentation. And underneath that, on 23 through what looks like 36, we've got return new promise. So we're going to be doing a promise here. The promise is going to resolve with a status code of 200 with headers of access control allow origin. That's a really big one. When you're building these Lambda functions and it has an API gateway in front of it, these access control allow origin headers are going to be important to be able to send back the response to the client. So if you don't have that, you're going to run into some issues where it works in Postman, it works in Insomnia, it works when you're testing it in the API gateway console, but then when it actually comes to working with your real front end, it won't work. Then we have the body JSON.stringify, and it's just got some information there. I think overall, if I had to rate the structure of this code, I think that having async function and then having return new promise, where it's yeah, it's a little bit this code's a little bit hard to read. I think maybe how I would improve this is like line 23 through 36. I probably wouldn't use a return new promise there. I would have a single line after line 20. I would create a new line. I would copy line 32 where it says s3.getSigned URL. And there's actually a syntax that you can use where you can say await, so it's async function, so you can say await s3.getSigned URL, parentheses, put object, comma, s3 params, parentheses, and you can say dot promise, parentheses, like open parentheses, close parentheses. That dot promise one, that's going to automatically turn that request into a promise, so you don't have to have it wrapped in a promise. And then from there, you then set it as a variable. So we're going to say let s3 response or let s3 signed URL equal to s3.getSigned URL put object for s3 params. That'll then come back as that variable, and then from there we'll have that variable. We don't have this return new promise resolve reject, and all we'll do is just say return. So we'll say return, and then we'll have the object with the status code, the headers, and the body. We won't have to worry about having a nested promise here. And that's pretty much it. And so then it'll go back to the handler, and then it'll return the result. So it'll be the same thing, but you get rid of a couple of lines of code, a little bit more complexity there, and kind of a nested call that's it's kind of deeply nested inside of a async await function inside of a promise.
Now we need to just set up this environment variable upload bucket. So down here, I'll paste that in, and I'll put in the bucket name I created, which is jbezwer uploads. Okay, so that's all good. I'll save this function now. Now the next step is to change the execution role. Right now, this execution role only has the permission to call this Lambda function. But when you're using pre-signed URLs, you also need to give it permission to be able to access.
So what we're doing right here is that what James just did is he added that SDK call. And so what he's basically saying here, and I'll just re-say it just so that and make sure it's really clear. When you add functionality to the Lambda function, such as using the AWS SDK to perform an action inside of your AWS account, so that Lambda is going to go to the S3 service, it's going to make some action. So therefore, we have to make sure that the Lambda function actually has permission to do that. By default, they don't. So by default with AWS, because they follow least privilege practices, which means only have access to what you need access to, you're not going to automatically have access to make that S3 get signed URL request. So therefore, James is going to open up the Lambda IAM role that's attached to that Lambda function. He's going to open that up. It's going to already have some very basic permissions, and he's going to go in there, he's going to add an additional permission, which allows him to make that AWS SDK call.
Access S3 and put objects into the bucket. So I'll add an inline policy. I'll choose a service S3. And for actions, there's 3 actions I'm going to provide. The first is under read. I'll allow it to get objects. And then for writing, it needs to be able to put an object. And then because we're changing the access control list, we need it to change the put object ACL, give it that permission as well. For resources, I'll specify this one bucket. We don't want to be too broad. So I'll add an on. I'll enter the bucket name again, jbezwer uploads, and we'll give it star on the object name so it can access any object in that bucket. There's the on. I'll just add that. And then we'll review the policy.
So one thing that I'll say there, that UI flow that you just saw, it looks very easily done. I would say that looking at that, from my experience, I've had a better time. If I want to make a policy, I'll just look up the policy that's required. This may be a more advanced thing, obviously. But you can actually just go onto Google. You can search AWS S3. Well, you don't even have to do it that way. You can just look at what is the request that you're actually making, and it's like get signed URL, something like that. And you can actually get that permission from the AWS documentation and then just add a policy directly into the AWS console. And you can just add it using JSON. So if, for instance, you found a tutorial where you're working through it on AWS, they may just have a snippet there. And so the easiest thing to do is just copy their JSON snippet for that IAM permission, and then just add that directly into the policy by just hitting the edit and then clicking JSON. So you can go through this UI flow, or you can also do it manually and just paste it in there. And then when you get more advanced, the more advanced you get, the more it becomes easy to just write these things yourself. And that's how I usually tend to do it. And then also, of course, there's a whole bunch of resources out there. So if you're ever search for, hey, I need to do a signed URL or get signed URL for S3, somebody probably actually has a template for that already. Definitely don't want to reinvent the wheel, but there are some cases where learning how to write it from scratch is actually very helpful. When you're first getting started, definitely use the UI. As you get further along, try to write it manually. It's actually going to give you a lot of downstream benefits because you'll really understand how all the permissions work on AWS.
And I'll give this a name, jbezwer uploads policy, and create this policy. And that's now attached to the IAM role for this function. So now what we can do is we can test this function. So I'll click on test. First we have to configure a test event. We're not really using this, so I'll just call it test. And I'll click test again, and that succeeds.
Okay, so something that he just did there that I'm going to pause and highlight is that inside the AWS Lambda console, there's actually a button there called test. And so what he did is that he was able to test this function very easily inside of the console. So he was able to write the code inside the console. He was able to test the code inside of the console. And he's able to get the output of this back to him. So you can see there that after he clicks the execution result details, there's actually an object coming back. And if you remember his code, he was returning a new promise with an object inside of it. And the body had an upload URL, and that upload URL was being generated by calling s3.getSignedURL. And so you can see there the body upload URL, HTTPS, and you can see his bucket URL name there. You can see the random ID that he did, 426001.jpg. Remember that .jpg that he showed in his code? And then you can see AWS Access Key ID. You can see it expires. So this is where you can actually set when you want this get signed URL, when you want this to actually expire. You can put there's a signature that automatically gets placed there as well. And I believe there's also, yeah, so here's a Amazon security token that's in this as well. And there might be something else additionally in there, but yeah, so it's pretty much, it's pretty interesting. You can even see here the content type there, and content type is image, and you can see a %f, which is replacing a slash, and then slash JPEG. So it's got a lot of the information that we set up in that params. If we went back in time and looked at the code again, a lot of the things that we put into that S3 params, that's actually what generated this URL. And now we're basically seeing that response come back in the console. Down here towards the bottom, you can see max memory used. So you can see 89 megabytes. You can see the duration was 346 milliseconds. The build duration was 300 milliseconds. The actual duration was 203 milliseconds. So you can see there that you just got charged an extra 97 milliseconds on this function. May not be a big deal when you're working with like one request when it's free. When you start getting up to that 3 billion invocation range with some big enterprise clients, that serverless gurus work with, for instance, at that point, that extra 97 milliseconds over 3 billion invocations is actually going to add up quite a bit. But yeah, there's like something that I talked to somebody from swim.ai, who is the CTO of that company. And one thing that he was talking about is just that if you look here, what did we really do inside that function, right? What we did is we called one thing, we called s3.getSignedURL, and then we just returned it, right? And just doing that, which you would think would, it's got to be pretty fast. Just doing that took 300, let me see. It took 203 milliseconds. So just doing that one little task took 203 milliseconds. We were billed for 300 milliseconds, and the max memory there was 89 megabytes. So you can imagine that the amount of functionality that we're actually doing is not that big, but the duration of all this is actually pretty long. So obviously it doesn't matter when you have a background processing thing. It outweighs it because it's very easy to hook a Lambda function up to an S3 bucket, and the response time doesn't need to be like 10 milliseconds, right? But if you're working with a different type of application, that small amount of code took 200 milliseconds to execute. It might be faster. Maybe this was a cold start, but I don't imagine it was a cold start. So because I imagine that he didn't import any libraries and that he just had the AWS SDK. And I think by itself, the AWS SDK is right around 5 megabytes. Maybe it's a slightly more, but I don't imagine the cold start being very big on this function. And so that just makes me think that what we saw here is there's a very slow response from this Lambda function for not a lot of workload. And that's something I'm starting to explore right now. I don't really have any I would still use AWS Lambda all day. I would still choose that as an option. If my application required some very high traffic usage where I needed this like really fast responses and I couldn't do that with AWS Lambda without spending a ton of money, then this is kind of me getting at like where is the breakdowns with serverless. That's one of the breakdowns currently. This small request took 200 milliseconds to finish.
And inside the response, you can see there is a pre-signed URL starting just there all the way, and that contains the token needed to be able to do the upload. So next I'm going to add a trigger. We need to make this accessible by the outside world. So I use API Gateway and create a new API. I'm going to use one of the new HTTP APIs. This is going to be open. So I'm going to turn on CORS just because we're testing.
Okay, so one thing here is that we're starting to hook up an API to this. So remember when I brought up that access control allow origin header? At the time he didn't mention this, so it's like why do we have a header on this, right? Like why are we trying to return this? But now we're actually connecting that to to API gateway, and what we're doing is we're connecting it to a new service that came out recently called HTTP API. So the HTTP API is a very scoped down version of the API gateway before, right? So it uses API gateway functionality. You're still going to have the similar concepts, but it's going to be cheaper. It's going to be lower latency. It's going to be a little bit easier to use and configure as the bullet points up there say. And with that, people are going to get a lot of benefit out of just having these very solid defaults, right? So the thing that makes a service stand out is really good defaults. So with API Gateway, it's super robust and you can do a lot of stuff. But the HTTP API kind of takes all this good stuff and just kind of puts it into the service automatically. And then you don't have to configure all these things by yourself, at least not all of it.
And I'll add this. This is accessible by anybody in the world. So now we have an API endpoint for our function. I'm going to copy this to the clipboard.
I'm going to pause it here for 1 second. What I want to look at here is that you can see we have the get pre-signed URL, and you can see this little line underneath it that connects to something, right? So you can see here that on the left side we have API Gateway, and there's a little line that connects API Gateway to the Lambda function. So this would be a trigger that's going to trigger the Lambda function, right? So this could also be an S3 bucket, right? So API Gateway to a Lambda function, or S3 to a Lambda function, and then the Lambda function can then invoke something else. So the Lambda function could invoke, another Lambda function, or an SNS or SQS or something like that. Yeah, hopefully I'm saying that correctly. Maybe I'm potentially off there, but the destination part is throwing me off because I just added in Lambda destinations. So, but yeah, basically this is a mapping of like how your Lambda function actually connects with things, yeah, so you can have triggers on one side, destinations on the other. Things can connect to your Lambda function. Your Lambda function can connect to other things.
Now what I'll do is I'll use Postman just to make a request to show how this could work. So we'll call the same endpoint, send that request, and again you can see the upload URL has come back in the response.
Okay, so let's take a look at what's happening here. He copied that HTTP URL that was attached to that Lambda function. He then got the URL, put it into Postman, which is the HTTP client. He then ran that request, which is a GET request. The Lambda function then got invoked. The Lambda function then went and ran s3.getSignedURL, returned that response back, then returned that to HTTP API, and that HTTP API then returned it back to our client. And that entire interaction took 483 milliseconds. So for something that's very small like that, it took almost 500 milliseconds to actually get that response to go to Lambda, to go to HTTP API, to Lambda, to S3, then back to Lambda, then back to HTTP API, and then back to the client. So half a second for that. Maybe it's not the biggest deal. It's not the biggest thing in the world. However, when you build real Lambda functions, it's very easily you very easily get into the point where you're importing libraries, and that those imports are going to make your Lambda functions a lot bigger. The bigger that the Lambda functions get, the slower the responses are, and you see where I'm going.
We have a photo file name, which is a random number generated by the function. So I've created a very small Vue.js application to show you how this works. It creates the UI that you see in the bottom right that enables us to upload this. It's just a JS fiddle I've built here. So I'll put in that API endpoint, paste that in to show you how this can be used inside your front-end application. I just run this with the new code. I'll choose a file for my desktop. I've got a picture of my laptop there. I'll upload that, and then click Upload. So this is uploading directly to S3, not going through.
So let's pause it there and let's talk about that for a second. So we got a Vue.js application, we got some JavaScript, we got some HTML, we got some CSS. There's a button there that says Upload Image. When he actually clicks that, he's going to choose a photo, And then when he hits upload, that's then going to trigger a function in his code. That function is then going to make a request to his API URL, which he just did in Postman. It's going to return back a response that has the actual URL that he has to use to upload that image to the S3 bucket. Then his Vue.js code is actually going to use that URL, upload that image, and then now he's going to switch over, I believe, and he's going to show us that it actually uploaded.
Through a Lambda function or anything else. And if I just refresh the contents of the bucket, there you can see this new image. And I'll make this public so you can see.
So previously, when he set the cores configuration, we can now see why he did that. And so potentially, only feedback for this video is potentially the structure of it, or a high-level overview about the entire thing that's going to be built. That'll give a little bit more insight into how all these things fit together.
There we go, that's a picture of my laptop. Using a serverless approach to uploading files from an application is very easy. You first create a bucket, then build a Lambda function that makes the request for a pre-signed URL from S3. The function itself is only about 30 lines of code. Remember that the IAM role used by the Lambda function must have permissions to write the object to the bucket. I then put API gateway in front of my function in this case, so I could call an endpoint. This returns the pre-signed URL of S3 that contains a temporary access token, allowing the client application to upload directly to the S3 service. To download the examples from this video and deploy the application in your own account, visit this URL. The best part is that this can be used for existing server-based workloads as well as fully serverless applications. S3 is a web-scale service that can handle hundreds of thousands of users uploading files simultaneously. This can give you an enterprise-grade solution for your customer-facing applications. Thanks for joining me for this quick walkthrough. Happy coding.
Awesome. So that was a pretty good video. I think I think it's really good. I think I got a chance to also help point out some additional context around the Lambda function, the IAM policies, all that stuff. If you found this video useful, let me actually switch back to my real camera. Oh, I think there we go. Sweet, there I am. So this was Ryan Jones, Serverless Guru. Thanks for watching. Again, go ahead and hit the like button. Subscribe to the Serverless Guru channel. That's going to help a lot. And then also, if you have any ideas for future content or things that you would want to hear my opinion on, drop that in the comments. I'll read it, I'll respond, I'll make a video about it, and we'll get going. All right, thanks so much, and I'll see you next time.